The air compressor, it's something pretty much every shop should have. So in today's video, I'm going to be talking about how these air compressors basically work, the different types of air compressors, and I'm also going to talk a little bit about my system, some things I like about it, some things I change about it. Should make for an interesting video, so let's get started. What are the components of a basic air compression system? Well, you have basically four main components. You have a pressure holding tank, you have an electronic motor, you have a pressure regulator, and you also have a pump. So basically what happens, electric current goes into this motor turns on, it spins a pulley, which in turn spins a belt that goes to this single stage compression pump, and that compresses the air, puts it in the tank, and then when the pressure hits the governed PSI, which in this case it's 155 PSI, this pressure regulator tells the motor, whoa, shut off, tank is full, shut everything down. And then also, vice versa, when the pressure hits below that minimum threshold, it tells the motor, all right, we're getting kind of low, kick on the motor, let's get some air compressed back in this tank here. So that's basically the basics of how an air compressor works. There's really two types of air compressors. There's single stage air compressors, and then there's dual stage air compressors. This is a single stage air compressor. The advantage of a single, well, let me backtrack a second here. So a single stage air compressor is really within the pump, and basically it compresses the air once. The advantage to single stage air compressors are they are cheaper, and they're cheaper. When you get into dual stage air compressors, that allows you to run a bit more efficiently, they're a bit quieter, and also you can achieve higher PSIs. But when we start talking about dual stage air compressors, they start to get up there really in cost. So unless you're running a professional mechanic shop, and even so, depending on what you're doing, you really can get by just fine with a single stage air compressor. If you have a home handy shop or small garage like I do, single stage air compressor is fine. So with this single stage air compressor system, I can still achieve 155 PSI. That's what this thing's governed at, and that's actually a pretty darn high PSI for a single stage air compressor. Typically I see single stage air compressors cut out at like 120 PSI. So that's one thing that's really attracted me to this Porter cable unit. Now I bought this one at Tractor Supply probably 7 years ago now, and it's been serving me just fine. Now something to consider when you're thinking about buying your first air compressor is what kind of power do you have in the area that you plan to run your air compressor. Now this one is a 240 volt motor, so you need to have a 240 volt receptacle in your garage or in the local vicinity of this air compressor. Thankfully I have a plug over by my circuit breaker box that I use to power my welder. It's a 240 volt 50 amp receptacle, so that supplies me plenty of power for this unit. This motor only calls for 15 amps. I do recommend that you seek professional help when installing these electrically, because you do have to make your own power cord to run this. A few other quick things I want to mention about my air compressor. So my air compressor is a 60-gallon tank. Now if you're just starting out, you can get by fine with like a little pancake compressor. That'll do all the basic things you need it to do, such as filling tires, blowing out air filters, and just having that air wand to blow dust out of little things. That'll get you by just fine. But if you can afford it, if you have the means, try and go with a larger compressor, especially if you plan to be in the area that you're living in for a while. Like a 60-gallon, I'd say that's a good sized tank. The reason why it's better to go with a larger tank, well, there's a couple of reasons. For one, your air compressor doesn't have to cycle on as much, and this also opens up more possibilities, right? So with this tank, I can run pneumatic tools. If I get the proper filters, I can run an HVLP paint spray gun, so you can use this for paint spraying applications. And also with this tank, I can use it to run my plasma cutter no problem. With those smaller pancake compressors, I don't know if they have the means to run like a plasma cutter, but the smaller pancake compressors, I feel like they definitely don't have I believe they call it CFM, cubic feet per minute air, that you'd really need to run like a lot of pneumatic tools. But then again, everybody's going to electric, so how much longer a pneumatic tool is going to be around anyway? Okay, so once you have your air compressor set up, you need a way to pipe that potential energy throughout your shop to use it for various tasks. Now, my system definitely could use a few improvements, but overall it does the job just fine. The first thing that I would recommend is get a ball valve as close as you can to where air exits the tank. The reason you want to have a ball valve is you could spend days, you could spend months trying to get every little leak out of your air compression system. There's always going to be some leak beyond this ball valve. Like if I crack this open, hear that air rushing out? Like I've tried so many times, but there's always just going to be some kind of small leak in your system. So whenever you're done using the air compressor for the day, if you have a ball valve right where it comes out of the tank, you just throw that ball valve off, and it just saves you on electrical energy because this thing does not need to cycle on as much. Next thing I'd recommend is think about where you want to have your air ports. So I have an air port right here, and that's one of the closest ones to my workbench. So, you know, I'm within 10 feet, it's not too bad. What I would really like to do is run an air line up into the ceiling somewhere and have like a drop down air line that sits right about here. So when I need to blow out something on like a small engine, I just take that air cord, pull it down, and then it's right here. It's a little bit of a pain, but it does the job just fine right there. Also beneath this port right here, there's a blue line that runs down along the edge of the garage foundation. And this is nothing fancy, it comes out right here. And this is what I use to fill up car tires, and I'm actually using this with this little accordion hose. I really like this accordion hose. I use this a lot, like right outside the garage to blow out air filters and like the filter in my shop vac, and just blowing dust off myself when I'm done for the day. So the easier it is to access your air compressor hose, the more you're gonna find that you use it. I wanna jump back to these pipe threads for a minute. I know I'm jumping around a little bit here, but a word of advice. In my experience, I've tried all different types of things to seal up these joints. I really don't like pipe dope. Pipe dope is like that stuff in the jar that you take and it's kind of like a gloppy, crappy substance, and you just glop it on the threads. I've never had a good experience with pipe dope. I always find that stuff leaks. The white tape, the white PTF tape, I feel like it works okay, but it really requires a lot of wraps. The stuff I really like to use is this Blue Monster PTF tape. I've had the best experience with this stuff. I don't know why, but it just seems to work a whole lot better, and you can clearly identify where I've used the Blue Monster by seeing the blue tape. Like I actually had a leak in this main cork right here, and this Blue Monster did take care of it. And now I did buy this stuff with my own money. This is not a sponsorship in any way, but just a word of advice. I like Blue Monster. I think this stuff works the best. Now I want to end this video stressing the importance of maintaining your tank, and I really want to give you a word of caution here. When you bring one of these into your garage or shop, you're basically bringing a bomb into your garage. I hate to say it, but that's basically what it is. You know, if this thing were to let go at 150 psi right now, I'd be a goner. If I was at the other side of the shop and it were to let go, I'd probably lose my hearing, but I'd live to see another day. Why do these things fail? The main reason air compressors fail and explode is because people don't drain the tanks. Now, I feel like that's partially the air compressor manufacturer's fault because they never really designed an easy way to drain the tanks. I designed a better system, I'll show you that in a minute here, but when I first bought this tank, it had one of those pain in the butt twist drain petcocks, and it, you know, every time I wanted to drain the tank, I'd like take 5 minutes to spin this thing, let it drain out, spin it back on it. Like, nobody wants to spend 5 minutes draining their air compressor tank on their hands and knees, so I came up with a better system. Basically what I did, I took that petcock out, I put a 90-degree valve in the bottom of the tank, and then a little extension pipe, and then a little ball valve. So now when I want to drain my tank, I just get underneath here, throw this little ball valve, find a place to catch the moisture that collects in the bottom of the tank, and it blows right out. No problem, takes a couple seconds, done. The other thing I like about my system is that any moisture that would normally collect in the bottom of the tank will sit in that elbow in that pipe that connects to that ball valve. So now all that moisture is outside of the tank, it's in this little elbow down here, and if that elbow or those connecting pipes to the ball valve were to fail, it wouldn't be a big deal. It'd just be like breaking an airline, right? So you'd get an extremely high push of pressure through a small orifice, but you know, you'd live to see another day. You're not talking about an explosion, you're talking about a get really noisy, but you'd be fine. So also, when you finish watching this video, go online and look up air compressor failure. I really want you to look that up because you'll find a video of a mechanic who had like a 10-gallon air compressor in his shop, one of the air compressors that sits sideways. And I think he said it was like 15 years old. But what happened with his air compressor is it sat sideways, and the seam for the tank, the weld for the tank, was at the bottom of the tank, and he didn't drain it frequently. So that water just sat on that weld. And over the course of 15 years, it ate away at that weld, and ate away at that weld. And then one day, when the air compressor was pressurizing, that weld gave way, and the whole tank just blew apart. It like blew out the windows in his shop, and thankfully he didn't die, but I think it's a real eye-opening experience, you know. So drain your tanks and just be careful out there. Let me take you under the air compressor now and show you my setup. All right, so here we are at the bottom of my air compressor, and this is the drain system that I kind of came up with. Again, it's just a metal elbow, a black pipe elbow, a black pipe, you know, nipple, and then I have a brass ball valve. So every time I want to drain the tank, I got a little catch pan over here. It's a good idea to wear some gloves in case some stuff shoots out of this, but crack this, you could see a little bit of moisture coming out of there. Not too bad. There were a couple drops that came out. I don't know if the camera's picking that up, but it's not too bad. And again, the advantage of building a tank drain system like this is, again, the moisture is just going to sit in this little pipe right here as opposed to sitting in the bottom of the tank. So I'd highly recommend that you make something like this if you have an air compressor. It just makes it so much easier to drain your tank, and you're going to find yourself doing it a lot more.